In our next section, we're going to talk about high availability for LAN connectivity on the UCS, and specifically look at what happens when a VNIC that is pinned to the A fabric loses connectivity, and then how we can move that VNIC behind the scenes over to the B fabric in order to transparently accomplish what we call fabric failover. So as we previously talked about behind the scenes, when we look at kind of the physical / logical view of what's going on inside of the chassis, the physical chassis has two different I/O modules or two different fabric extenders that are connecting up to Fabric Interconnect A and B respectively. Now we saw as part of the service profile when we were defining the virtual NICs, we have to manually assign whether the VNIC is going to be pinned to the A fabric or the B fabric. We can't choose both, which means it cannot do a load balancing between the two FIs. What we can, however, configure is the availability for the VNIC to move from the A fabric to B if there's an uplink failover or vice versa. Okay, so first I want to show what is the current behavior when we do not have fabric failover configured. We'll look at what happens in the failure situation, and then look at how do we configure fabric failover in order to resolve the type of issue that we're going to run into. Okay, so again, if we go back to our jump box that is connecting to the UCS manager and then also to the blades, we have two different blades booted. So if we go back to the KVM, we have two different instances of VMware that have the IP addresses 10.0.0.102 and 20.0.0.101 respectively. And we can see from the top of the KVM, these are associated to chassis number 1, slot number 4, and chassis number 1, slot number 5, respectively. Okay, so two different service profiles going to two different physical servers. From the jump box is in the VLAN 10 segment, and it has routing reachability to its default gateway. We can see the end result is we're able to ping both of these endpoints, the 10.0.0.102 and the 20.0.0.101. Okay, so next, if we take a look back at our physical topology, what I now want to know is what happens when we lose some of the uplinks from the Fabric Interconnect's point of view. So what is it going to do with this LAN traffic if the uplink that it's pinned to is no longer available? So from the 5Ks, let's look at first what MAC addresses are these two IPs corresponding to. So we need to look at the ARP cache, and we're specifically trying to reach 10.0.0.102 and 20.0.0.101. So let's show IP ARP, and then we're going to show MAC address table and pipe to include both of these addresses. Okay, so the 008F, that's the VLAN 10 NIC, and then the 0001, this is the VLAN 20 NIC. Now, as it stands, we should see that both of these MAC addresses are equally reachable over the port channel. Port channel number 1 that's going down to Fabric Interconnect A. This is from both FI, or both from 5K1 and 5K2, because they both have a VPC, a virtual port channel that's going down to Fabric Interconnect A. This means that from Fabric B's point of view, we should see that these two MAC addresses are not going to be learned, because recall that the Fabric Interconnect only learns southbound facing MAC addresses. It does not learn northbound addresses. So FIB doesn't know that these are reachable through the 5Ks. In order to actually get to these addresses from the B fabric, we'd have to follow our static pinning decision that the virtual NIC of the actual service profile is going to be bound to the upstream port channel. We would have to switch the traffic up to the 5Ks. 5Ks would then either bridge the traffic at layer 2 or route the traffic at layer 3 down to these particular destinations. Now, from Fabric A point of view, since both of the VNICs are pinned in this direction, it should mean that we're learning both of these, and notice that they're corresponding to two different virtual Ethernets, VETH 698 for VLAN 20 and VETH 702 for VLAN 10. If we were to then look at the show pinning for interface VETH 698 and VETH 702, we see that both of these VETHs are pinned to port channel 101, which is the VPC going northbound to both 5K1 and 5K2. So in other words, from a physical connectivity point of view, as long as Fabric Interconnect A has at least interfaces 3, 4, or 5 available, the port channel should stay up, and the pinning decision should be still valid as we're going from the VLAN 10 NIC northbound and going from the VLAN 20 NIC northbound. Okay, so next let's look at the case where all of these interfaces fail. So we're going to go over to 5K1, we're going to shut down ports 9 and 10, and then on 5K2 we're going to shut down port 11. And we want to see what this is going to do to the connectivity from our virtual machine, both to these hosts. Okay, so let's go over to 5K1, and we're going to shut down interfaces 9 to 10. Okay, so interface E1, 9 to 10, shut. We should see that this does not impact connectivity down to the VMs, because from 5K2's point of view, if we look at the show MAC address table, we should still see that these are reachable via the VPC member. From 5K1's point of view, these should change over to port channel number 34, where previously they were on port channel 1. Now they're going to move over to 34, which is our VPC peer link. So 5K1 receives any layer 2 traffic going to either of these MAC addresses has to go east across the port channel to 5K2. Then 5K2 has reachable on the VPC member, okay, port channel 1 down towards the final destination. Okay, so as long as one of the interfaces are up, then no connectivity problems. Okay, but now on 5K2, we're going to lose that leg of the channel as well. So if we look at the show port channel summary, port channel number 1 is on interface E111. We shut this down, and we should see now from the end host point of view, end result is now we've lost IP connectivity to both of the machines. Now the reason why here is that by default, Fabric failover is not enabled. This means that if we lose all of the uplinks, either from the chassis to the I/O, or not from the chassis to the IOM, that would be internal to the chassis. But if we lose the links from the I/O module to the Fabric Interconnect, or the Fabric Interconnect loses its northbound links to the network, it means that the OS doesn't automatically know to move the traffic over to Fabric B. Now, we could potentially solve this issue from the OS level by telling VMware to use the alternate network card in order to reach the northbound network. But essentially, we would have the same type of problem just in the reverse direction, where Fabric B would be a single point of failure in addition to Fabric A. So let's go to the KVM of both of these. And I'm going to edit the networking config. So this is F2 to customize. Then the password should be CCIE DC01 with a capital C. F2 again. We're then going to go down to configure management network. Under network adapters, I'm going to move the adapter. Okay, notice that this says is disconnected because the UCS Fabric interconnects are telling the blade that you've lost connectivity to this Ethernet. But I'm going to unselect the first one and move it over to the second. Okay, then escape, or actually not escape, I should have hit enter. So enter to accept, hit escape now to restart the network. Okay, yes, I want to restart the management network. And what we should ideally see is that we now regain connectivity to this end host. If we go now to the 5Ks and look at the MAC address table, we should see the MAC address is now moved over to port channel 102. Okay, so let's ping to the destination. Let's ping 10.0.0.102. Okay, we're now able to reach it. And we should see, actually now it has a different MAC address. Let's say show IP ARP. And we're going to show MAC address table, pipe to include that number. We should see that from both of the 5K's point of view, we now have reachability to the address on port channel 2. But notice here additionally that the MAC address changed. So we're effectively just fixing the problem by using a different adapter. It doesn't necessarily fix the issue where VMware sees two different uplinks, VMNIC 0 to Fabric A, VMNIC 1 to Fabric B. Fabric A is lost. The OS, VMware, doesn't know to automatically move the link over from one fabric to another. Now, when we make this change, we'll see that this does count as a hardware change, which means that we will need to do reassociation of the service profile back to the blade. Or in other words, we need to reboot the server in order to get this functional. Okay, so let's go back to the UCS Manager, and we're going to edit this for both of the service profiles. Now, before I make this change, what I'm going to do is there's something global here that I want to modify in the UCS itself, which is going to be under Server Policies. So we're going to go to the Server tab, then we're going to go under Server Policies. So click the drop-down, Server Policies, and what we're going to edit is the default maintenance policy. Okay, the maintenance policy controls when you make a change to the service profile. Do I want the system to immediately reboot the server and apply the change, or do I want it to ask me, do you want to apply this change, yes or no? In most practical cases, you wouldn't want it to just reboot the blade anytime you make a change, but be aware that that is the default behavior. Okay, and specifically, this is controlled by the reboot policy, which is immediate in the default maintenance policy. So if we wanted to change this, we could either change the default maintenance policy, and I'm going to change this to user acknowledgement, okay, saying that I have to agree that I want the change to apply. Okay, the other option would be that I could define a user-defined maintenance policy. Okay, so I could create one, and I'll say that this is user ack on reboot, and okay, ack on next reboot. So we say user acknowledgement, and I wanted to apply the changes on the next boot. Okay, which basically means that if you reboot the server for any reason, let's say you're upgrading VMware, patching some code version on it, you reboot the blade, it also means that the UCS manager is going to know that and then reapply whatever changes that you have queued up for the service profile, like maybe adding a new NIC or changing the MAC address, changing the port worldwide name, anything that the server sees as a physical change, which from our point of view is really a logical change. It's just a reprogramming of the chips, like flashing the EEPROM on the board. But in order to do that flashing, it requires a reassociation of the service profile. And now, in my particular case, this one that is called ack on reboot, I haven't assigned this to the service profile, so it means that the default maintenance policy is still going to take precedence. Okay, unless there's one defined, we're going to choose the default option for any of these. Okay, so next we're going to go under server profiles, the service profiles, and we're going to edit the virtual NICs of the profiles. Okay, so right now NIC1 has an error. If we go under faults, it says problem is linked down. Okay, the host adapter is down. The reason why is that the physical uplinks from Fabric A northbound are lost. Okay, so this is not a configuration error in our case. It's basically a physical failure that's saying that, hey, the link is down. Okay, so what we're going to do is under NIC ETH0, we're just going to check this box that says enable failover. Okay, so save changes. And we're going to do the same thing on all 4 of these NICs. So we have ETH0 and ETH1; those are on Fabric A and B respectively. And then likewise for profile number 2, we have ETH0, ETH1; these are pinned to A and B respectively. Okay, so we're going to go to ETH1, enable Fabric failover, hit save. It says this will require user acknowledgement before a reboot. Okay, in the previous case, since I had the default maintenance policy to immediate reboot, it doesn't ask you this, it just reboots the blade. The problem with that, of course, in production is that if you're making changes outside of a maintenance window, you just power the server off. But more importantly, assuming that you're planning this change out, when you specify user acknowledgement, you can queue up multiple changes to the same service profile at a time and apply them all at the same time as opposed to individually. So otherwise, if I had not modified the default maintenance policy, as soon as I had made the change on ETH0, it would have rebooted and started reassociation. I would have to wait for that to complete before the second change is implemented, which is on ETH1. So by doing the user acknowledgement, I can have it program both changes at the same time instead of going through 2 separate reboots, okay, which is going to be the ideal case. Okay, same thing is going to be true here on profile 2. So we go to VNIC ETH0, enable Fabric failover, save the changes. It says you're going to require to acknowledge, yes. And then the same thing on ETH1. So ETH1, Fabric failover is enabled, and then save. Okay, now additionally, if we go up to the top of the window, what we should see in the UCS Manager is now that this pending activities is flashing. So we click on pending activities, it shows us what changes are now queued up. So for the service profile, Brian Profile 2 and Brian Profile 1, both of them are waiting for me to say, yes, I want to do the rebooting. So I can check these individually, or I can just say acknowledge all, and then OK. Okay, if we go back down to the KVM, we should see that now the servers are going to reboot. But keep in mind, this is not a quick process. It's going to take maybe 10 to 20 minutes. It's kind of variable depending on the hardware generation of the blade. Also depends on whether it has to do a full hardware power on self-test. Like if we're checking the memory and your blade has a terabyte of RAM, then it's going to sit there at the splash screen for quite a while it's doing this, hardware checking. Now, in my particular case, the blades are basically minimum config. They only have 8 gigs of RAM each, so it's not that time consuming. But be aware that if you do this in a real production design live, that it's not the same as like doing a vMotion in VMware. It's not immediate. It's going to take a while for it even to get the notice to reboot. So you can see it take like maybe 30 seconds or so before the changes start to apply. And we should see then that when the signal comes back here and we get output to the video, we should see that it's going to write the changes. Okay, so I'm going to just leave this screen on here, pause the audio for a minute. It's going to take a couple minutes for it to go through the post process in order to actually write the new changes. And then hopefully what we should see once this is done, Fabric failover is going to kick in, and then we should be able to regain connectivity to both of these NICs. Okay, so we should see that the pings are going to succeed both to the VLAN 20, which is the one at the top, and the VLAN 10, which is the one on the bottom. Okay, any questions up to this point on what we're changing here in the design? Okay, we see now it says Cisco VIC-FC boot driver, so this is where it's attaching to the SAN. If the output of this is correct, we should see the port worldwide name of the target, which we do in this particular case. So there's two different targets. We have a target on A, we have a target on B. Same is true with the other profile. Okay, now it's going to go through the rest of the boot process. So we can see now both of the hypervisors are done booting up. And if we look at the network connectivity behind the scenes that we're pinging both of the management IPs, we can see that our jump box has IP reachability to both of them. So to 10.0.0.102 and then 20.0.0.101. Okay, so next let's look at the Fabric Interconnect and see which way it's actually pinning these virtual NICs, whether they're going to the A fabric or to the B fabric. So to figure this out, I need to go to the FIs and we need to look at what virtual Ethernets are assigned to the blade. So from the CLI, we're going to figure this out by looking at the show interface, and then we're going to pipe to include the keyword server or capital VETH. And specifically what we're looking for is server 1.5 and server 1.4. What are the virtual Ethernets that correspond to the logical cards? Now notice here that from Fabric Interconnect A, the output is different from the previous case where we did not have Fabric failover enabled. That on Fabric A we had ETH0 for both profiles. On Fabric B we had ETH1. But now notice with Fabric failover enabled, we have both ETH0 and ETH1 existing on Fabric A. And the same is going to be true on Fabric B. So if we go to FIB, look at the show interface, pipe to include server or VETH, we see that we have server 4 and server 5's ETH0 interfaces and ETH1. Okay, additionally, notice from Fabric B point of view, all of these 4 interfaces are up. Okay, so line protocol is up. On Fabric A, all 4 of these are down. The reason why is that A doesn't have any physical connectivity northbound to the 5 case. So I'm going to go to 5K1, 5K2, and we're going to unshut the interfaces that we had previously disabled. Okay, so this is 9 and 10 on 5K1, and this is a port 11 on 5K2. Okay, so no shut. If we look on fabric A, we should ideally see all 4 of these interfaces now come up. Okay, 706 is up, 707, 709, 7012 is now up. Okay, so let's go back to the jump box. Let's see if we're maintaining IP connectivity. Okay, which we are. Okay, so we have reachability to both. If we go to the 5Ks, let's ping these addresses. And we need to find the MAC addresses, so let's ping to 10.0.0.102 and ping to 20.0.0.101. And then let's show IP-ARP pipe to include 10.0.0.102 or 20.0.0.101. Okay, we see both MAC addresses. Then let's look at the show MAC address table. Pipe to include these 2 addresses, so 009F or the 0001. Notice that both of them are starting with the same prefix because they're coming from the same default MAC address pool that I had defined under the root org as default. So all of the service profiles, or both of the service profiles in this case, are going to be pulling from that space. Okay, so now we're learning these 2 different directions. Port channel 1, port channel 2, these are going to fabrics A and B respectively. Okay, port channel 1 is the VPC to FIA, port channel 2 is the VPC to FIB. And then same thing is true on 5K2. Okay, the reason that they're going in different directions now is that if we go back to the jump box, let's go to the KVM, and then we're going to edit the networking config from the VMware point of view. Okay, so again, we hit F2, then password CCIEDC 01, okay, with a capital C. Then we hit F2 again. Okay, we go to Configure Management Network. Let's go to Network Adapters. And then we see one of them is, actually both of them are using VMNIC 1. Okay, so we can see the MAC addresses there of where these are located. That MAC address 0001 is VMNIC 1 from this hypervisor's point of view. When we map this to the physical network, we saw from the 5K's point of view that when we looked at the ARP cache, the 001 or the 0001 MAC address was corresponding to 20.0.0.101, and this is pinned to fabric A. Okay, if we look at the second one on the right, the 009F, the 009F is pinned to fabric 2, okay, pinned to fabric B. Now again, notice that the hypervisor on the left here, we now have an additional problem that we had talked about before that relates to the PCIe and VHBA, the VNIC VHBA placement policy onto the PCI bus, where from the UCS point of view, we have ETH0 and ETH1, but those got switched from a logical provisioning point of view. So the UCS sees ETH0, VMware is seeing VMNIC 1. UCS is seeing ETH1, VMware is seeing VMNIC 0. So to make sure that this matches 100%, we would need to re-provision the PCI placement policy, but that does require another re-acknowledgement. Okay, specifically where this would be if we go back to the UCS manager, we're going to go to Profile, Brian, Profile 1. And then under the main page, so just under General, towards the bottom, we're going to change the VNIC VHBA placement policy. Okay, right now it says we're letting the system perform placement, and notice what's happening is that ETH1 got placed before ETH0 on the bus. Okay, so we're going to manually place this. We're going to place it with the VHBAs first. Okay, so FC0, then FC1, then ETH0, then ETH1. Okay, the VCons, we'll come back and talk about this later when we talk about the blade physical design behind the scenes. Okay, so we're reprovisioning, then down towards the bottom it says this will require user acknowledgement. Okay, so we should see the top button, pinning activities, now starts to flash. Okay, click OK, then we need to go to pinning activities and we need to acknowledge. Okay, so this is going to reboot this guy again. Okay, while we're waiting for this to come back, let's look at the other profile that's currently working, which is going to be this one here. Okay, so chassis 1 server 4, and this has the MAC address that is 009F. Okay, so let's see which fabric that this is pinned to. Ideally, VMNIC 1 should be on fabric B. VMNIC 0 should be on fabric A. So let's go to the FIs and look at where they see these MAC addresses. So 0000, 8F, and 9F. Okay, so on the FIs, let's look at the show MAC address table, pipe to include 8F or 9F. Okay, we want to look at both of these. So FIA sees the 8F on VETH 709. Okay, this one is pinned to fabric A. Fabric B should see 9F. 9F is VETH 711. Okay, so notice here that the same MAC addresses do not exist on both ends of the fabric. Because even though they have that L1, L2 link that is synchronizing the config, what we do not have is a control plane synchronization between the two. Okay, so one sees one sees the other. They're both in VLAN 10, but they're different interfaces from the OS's point of view. Okay, we go up to the northbound switches, and what this is corresponding to, let's escape here out of this editing screen. This is corresponding to the IP address 10.0.0.102. Okay, so we should see that we still getting connectivity to that. The other one is timed out because the server's rebooting. And if we look at from the 5-case point of view, let's see which MAC address corresponds to 10.0.0.102. Okay, it's either going to be the 8F or the 9F. So let's show IPR pipe to include 10.0.0.102. And this is going to 9F. We saw that 9F was pinned to fabric B, which means that the 5K should be learning this MAC address out port channel 2, which is the VPC that's going to fabric B. So if we show MAC address table, pipe to include that value. Port channel 2, if we show port channel summary, port channel 2 is going to port 11. If we show interface E111 or show CDP neighbors on interface E111, this should go to fabric B. Okay, same thing on the other side. On 5K2, if we look at port channel 2, this is ports 9 and 10. If we show CDP neighbors on interface E19 and E110, these are going to fabric B. Okay, this means that the virtual NIC, from the Blade's point of view, is leaving the VIC adapter, going through the backplane up to IO module B. IO module B is then load balancing the traffic up to Fabric Interconnect B. Fabric Interconnect B is then pinning it to the northbound logical port channel. Then we would be load balancing the traffic between the physical ports. But the key point about this is that if we look back at that physical/logical diagram, from the OS's point of view, it doesn't know which way the NIC is actually going. Okay, so from the OS's point of view, we're running ESXi. It sees logically VM NIC 0 and it sees VM NIC 1. But when these go to the adapter, we don't actually know which direction they're going. Now, from the UCS point of view, we do know because we pinned NIC 0 up to Fabric A. Okay, so this is VNIC ETH 0. And then we had a separate VNIC that was ETH 1. ETH 1 is pinning towards Fabric B. From the OS's point of view, OS is using VMNIC 1 as the management port. This means that VMNIC 1 is pinning to ETH 1. ETH 1 is pinning up to Fabric B. Fabric B then goes up to, or the IO module B goes up to Fabric Interconnect B. Fabric Interconnect B is then going two different ways. It's going to 5K1 and 5K2. But from its point of view, this is a single logical port channel. Okay, because remember, these guys are in a VPC.